This lesson goes along with section 6.2 in digits, and we are going to determine how many solutions a system of linear equations has, based on the equations that are given. By now, you should understand that the solution to a system of linear equations occurs where the lines intersect. So again, the solution occurs where the lines intersect. So we need to think of the possible situations of graphing two lines on the same set of axes. So let's take a look at a graph, and one case is where we have two lines that intersect. So the point of intersection right here is the solution. So this is a case that has one solution. A second case is where you have two lines that never touch. So if you have two lines that never touch, there won't be a solution. And we call these kinds of lines that never touch parallel lines. So there is no solution if this is the case. A third case looks kind of strange. A third case is where we have a line, and then a second line is placed directly on top of the first line. So if you were to just look at the graph, it looks like one line. So this is the case where one line is on top of another line. All right, now we know the three different cases. Let's examine what the equations look like for each kind of example. All right. The first example is where we will have intersecting lines. And an example of a system where they have intersecting lines is y equals x minus 1 and y equals 2x minus 3. So in order to see what is happening here, we need to remember that our y-intercept is what we add or subtract at the end. So I'm going to plot the y-intercept first. And then I go to the slope, and the slope is the coefficient in front of the x. In this case it's 1, so I'm going to put 1 over 1. So that tells me I rise 1 and I run 1. So I go up 1 over 1 from my y-intercept. So I'm going to cover the entire grid so that I have a nice, neat, straight line there that I could connect the points to. So that's the first line. The second line has a y-intercept of -3. So I start on the y-axis at -3, and my slope is up 2 over 1. So I have a point there, I go up 2 and over 1, I have another point there, and I continue that pattern all the way across my grid, and I go in the opposite direction, so down 2 and left 1. And I have my line for the second equation now. And knowing that a solution to a system of equations is where the two lines intersect, I see that I have a solution right here. And if you look at the coordinates, remember our coordinates are listed with the x value first and then the y. So our coordinates are 2, 1. So the answer or solution to the system is the point 2, 1. I can check that by plugging it in. My x value is 2 and my y value is 1. So we have the equation 1 equals 2 minus 1, which is true. If I plug it into the second equation, I have 1 for my y and 2 for my x. So I would end up with the equation 1 equals 2 times 2 minus 3. And if I simplify that, that's 4 minus 3, which is 1. So that works out as well. So that's an example of intersecting lines. If we move on to an example of lines that never intersect, which we call parallel lines, I have an example here of a system of parallel lines that is y equals 3x plus 2 and y equals 3x minus 1. So let's graph these. My y-intercept is 2, so I start on my y-axis at 2. My slope is the coefficient in front of the x, which is 3. I'm going to make it a fraction, 3 over 1. So that means I rise 3 and I run 1. Rise 3, run 1, and I continue the pattern in the other direction. Down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1. So that gives me enough points to graph my line accurately across the entire grid. And now we're ready to graph the other example, or the other equation. So my y-intercept is negative 1. My slope is 3, so I'm going to go up 3 over 1. And I continue that pattern, up 3 over 1. And I go in the opposite direction as well. Down 3 and left 1. Down 3 and left 1. So that gives me enough information there. Connect the points with a straight edge. And you can see that the two lines will never touch. When that happens, there is no solution. Because remember, the solution to a system is where the two lines intersect. Since these don't intersect, there is no solution. So we can write the words no solution, or we can write that symbol, which means no solution. And let's go to our third example, and that was where one line is on top of another line. So let me show you an example that looks like that. So this is the third case. One line is on top of another. Here's an example of one. Y equals 1/2 x plus 3. And the other equation is x minus 2y equals negative 6. So let's go ahead and graph the top one. The y-intercept is 3, so I start up at 3. And my slope is up 1 over 2. So I go up 1 and right 2, up 1 and right 2, and I continue that pattern all throughout the grid. going in both directions. Down 1, left 2. Alright, that's enough of my plotting, so now connect the dots. And that's the top line. Now, for the bottom line, there are a couple of ways we could do it, and this was in a previous video. One way is to get it in slope-intercept form, and that's what I'm going to do now. I'm going to get it in slope-intercept form by isolating the y, which means I need to subtract x from both sides. If I subtract x, that gets rid of this x on the right, on the left. The negative 2y drops down. And then remember, we like our x's first, so it's negative x plus negative 6. Or you could just put minus 6 if you wanted. And then our next step is to isolate the y by dividing by negative 2 on both sides. Now, when we do that, the negative 2's cancel, and we're left with y on the left. And then here we have a negative x, or really that's a negative 1x over negative 2. Negative 1 over negative 2 becomes positive 1/2 x. And then we have over here a negative 6 over negative 2. So that's a positive 3. Now, if you take a look at the equation that we came up with, y equals 1/2 x plus 3, you can see it's the exact same thing that we had there. So the y-intercept is 3, and the slope is up 1 over 2. And you can see that all of the points that I'm plotting now are on top of the previous line. So that means that the line is on top of the first line. When that happens, the answer is where the lines intersect, and they intersect at several, actually infinite number of points. And because of that, we write that this has infinitely many solutions. And that happens when one line is on top of another. Alright, now it's time to make some observations. So what we're going to do is we're going to go back to the intersecting lines slide. Take a look at why these two lines intersect. When the lines intersect, look at this part of the equation. You should notice that I'm circling the slope. When the slopes are different, that means the two lines are going to intersect. If you take a look at parallel lines, and I circle the slopes are the same. When the slopes are the same, we might have parallel lines. If I look at the next one, again, here's my slope for the first one, and here's my slope for the second one. They are the same. So that means if the slopes are the same, we could either have one line on top of another, or we can have parallel lines. So what determines if they're parallel or on top? That's where the y-intercept comes in. If they have different y-intercepts, they're going to be parallel. But if they have the same y-intercepts, one line is going to be on top of the other. So let's write some of those observations out. You will need to pause your video to copy this next slide down. Please pause the playing of this video and copy down these very, very important observations. And once you're done copying those down, move on to these following examples. We are now going to do 3 examples, and the requirement is to determine how many solutions each system has. So, for the first example, we are going to start with the system y equals 4x plus 2 and y equals 4x minus 1. So to figure out how many solutions this system has, the first thing we look at is the slope. If the slopes are the same, that narrows it down to either parallel lines that have no solution or one line on top of the other, and that has infinitely many solutions. So this is the same slope. So after we look to see if it has the same slope, then we compare the y-intercepts. If they are different y-intercepts, that means that that means that they are parallel lines. And therefore, there are infinitely many solutions. And that's how we write the answer, infinitely many solutions. Any point on the line works in both equations. For our second example, we have the system 2x plus 3y, and I'm going to start a new page here. So 2x plus 3y equals 6, and 8x plus 12y equals 24. Now, we need to compare the slopes, and then we need to compare the y-intercepts according to what we have learned. So we're going to take some time here now to solve each equation for y so that we can compare the slopes. So let's take the first one. 2x plus 3y equals 6. We're going to work on solving that for y, so I'm going to subtract 2x from each side. The 2x's cancel, so the 3y drops down, and the x's want to come first, so negative 2x plus 6. Now we divide everything by 3, so we get y equals, and then I'm going to show you here, we get negative 2/3 x plus, and then here we're going to have 6/3, but that simplifies to be 2. So we get y equals negative 2/3 x plus 2. We're going to do the same thing with the second equation. So we have 8x plus 12y equals 24. We're going to solve for y, so subtract x from each 8x from each side. The 12y drops down, and we want our x's to come first, so it's in slope-intercept form. Now divide both sides by 12. We're left with y equals, which is what we wanted. And on this side, we have negative 8 over 12. And negative 8 over 12 simplifies. 4 goes into both of those. It simplifies to negative 2 over 3. We have our x plus, and then we're going to do 24 over 12, and that simplifies to 2. Now, since they're both in slope-intercept form, we compare the slopes. So the slope of the first line is negative 2/3, and the slope of the second line is negative 2/3. So that means they have the same slope. The y-intercepts are the same. So when the slopes and the y-intercepts are the same, that means that we have infinitely many solutions because it's actually the same line. And now I realize I was mistaken on the last one. So let's go back and fix that. Make sure that you fix this. We have parallel lines, and hopefully you caught it, but many of you may not have. Parallel lines means no solution. I apologize for that. Parallel lines, there is no solution. No solution. My apologies for that. Hopefully you did not just skip over this. So, parallel lines, no solution. All right, and then when we have the same lines, that's infinitely many solutions. All right, we have one more example, but before we do that, let's go back and observe our original problem right here. So, if we have this equation, let's take a look at it more carefully. Do you notice that if we can multiply everything in this top line by 4, we end up with the bottom line here. 2 times 4 is 8, 3 times 4 is 12, 6 times 4 is 24. So if you have something in standard form, which is what the black is, and you notice that you can multiply the top or the bottom by a number and get the other one, that means that they're the same line. So it's infinitely many solutions. All right, and the last example, we have y equals 2x plus 4 and y equals negative x plus 4. So the first thing that we want to look at is the slope. So the slope here is 2. The slope for the bottom one, remember that there's a 1 there, so the slope for the bottom one is negative 1. So we have different slopes. And if we have different slopes, I don't need to look at the y-intercept. It doesn't matter what the y-intercept is. If they have different slopes, that means that they are intersecting lines. And therefore, there is one solution. All right. So that sums up our lesson on how many solutions. It is now time to do a Google form to see if you understand the material. So here is the link. It is http://goo.gl/forms/lowercase capital S, lowercase ua, that is the number 0, Z, capital S. So this should work. Please go to the Google form and complete the quick questions.